In this video, I will be discussing about u-substitution. So what is u-substitution? U-substitution in our integration is an integration of the composition of functions. Actually, we've been using this u-substitution even in our previous videos, but here we spend a special episode for this u-substitution. So this big F of u is equal to the integral of the composition of functions f of the g of x times the differential of this g of x, which is g prime of x dx. So to convince ourselves that this statement is true, let us sketch a proof here. Let big F of u be a function whose differential of this big F of u is equal to the small f of u du, and our u is a function of x, which is a differentiable function of x. Say u is some function g of x, and its differential du is equal to the g prime of x dx. So suppose this is our equation 1 here, and this is our equation 2, and this is our equation 3. Then we say that the integral of our small f of u du is just equal to the integral of the composition of f and u, where u is some function of x, say g of x. So instead of writing u, I will write its function g of x from this equation 2. And instead of writing du here, we will write its equivalent value, which is the g prime of x dx. And the reasoning is taken from equation 2 and 3. Now, since this small f of u du, which is this one, is equal to the differential of our big F of u from this equation 1. So instead of writing this one, we will write its equivalent expression, which is the differential of the big F of u there. And this is equal to the integral of the small f of the g of x times the differential of the g of x. And the reasoning is from equation 1. Now we know that the integral of the differential cancels each other. So the big F of u is just equal to the integral of the composition of functions of f and g times the differential of g, which is g prime of x dx. And this is the goal, the statement that we want to show. So this u-substitution actually is an integration of a composition of two functions f and g, wherein the derivative of g is also found in the integrand. Now, to give you an illustration of this u-substitution, I will give my first example here. What is the integral of cosine of 3x over e to the power sine 3x dx? Now, looking at this integrand, it seems that it is not easy to integrate this integrand. However, if you represent the exponent of your e, which is sine 3x, as your u, so u is equal to sine 3x, we notice that if we get the differential of u, this is equal to the cosine of 3x times 3 dx. But we don't have this coefficient of 3 in our integrand here. So we divide both sides of the equation by 3. So this is equal to cosine of 3x dx. Now by substitution, we have the integral of this numerator cosine 3x together with the dx as your du over 3. So instead of writing that one, we will write du over 3. And the denominator is e to the power of u, because instead of writing sine of 3x, we will write its equivalent representation, which is our u. And now we can factor out the constant, which is 1/3. So this is 1/3 of the integral of du over e to the power u. But we can move this up in the numerator. So we have 1/3 of the integral of e to the power negative u du by applying the law of the exponents. And we noticed that the differential of negative u is not du, but a negative of du. So what you will do is you just add a negative here, but neutralize outside the integral symbol by another negative sign. So this is the negative 1/3 of e to the power negative u times negative du, because we know that the negative of the negative is positive. And we know that the integral of this is equal to e to the power negative u plus the constant of integration c. So substituting back our value of u, we have negative 1/3 e to the power negative sine of 3x. And this is added to our constant of integration c. And this is our final answer to this example here. Now let's proceed to our number 2 example here. What is the integral of the quantity 3x to the 5th power plus x squared times the square root of 3x cubed plus 1 dx? Now looking at this integrand, it's a product of this polynomial and this square root of another polynomial. But if you try to represent the polynomial inside this square root symbol, which is 3x cubed plus 1, we notice that the differential of our u is 9x squared dx. And with this, it is not so obvious that this one is already there in our integrand. However, if you factor out the common factor in this binomial, we have a common factor of x squared. So this is x squared times 3x cubed plus 1. And this is multiplied by this square root of 3x cubed plus 1 dx. Hence, we notice that this one and this one can be combined, because if you express our radical term to its equivalent exponential form, we have this as 3x cubed plus 1 to the power 1/2 dx. So applying the laws of exponents, we have x squared times 3x cubed plus 1 to the power 3/2, because we just add the exponent 1/2 and the 1 here, and of course there is a dx here. Now rewriting this x squared and this dx together, we have the integral of 3x cubed plus 1 to the power 3/2 x squared dx. And we can find that this one is here. So if you divide both sides of the equation by 9, we have du over 9, which is equal to x squared dx. So substituting our u here, instead of writing 3x cubed plus 1, we will write its equivalent representation, which is u. So this is the integral of u to the power 3 halves. And instead of writing x squared dx, we will write its representation, which is du over 9. So this is times du over 9. But we can factor out the constant here. So this is 1/9 of the integral of u to the power 3 halves du. And applying our power rule here, we have 1/9 of u to the power 5 halves divided by 5 halves. And this is added to our constant of integration c. And performing simple arithmetic here, we have 1/9 times the reciprocal of 5 halves, which is 2/5 here. And this is multiplied by our u, which is 3x cubed plus 1 raised to the exponent 5 halves. And this will be added to the constant of integration c. So our final answer is 2 over 45 times the binomial 3x cubed plus 1, which is raised to the exponent 5 halves, plus the constant of integration c. And this is our final answer for our example number 2 here. Now let's proceed to our example number 3 here. What is the integral of x times x squared plus 1 times the square root of 4 minus 2x squared minus x to the power of 4 dx? Now looking at our radicand here, we suspect that that would be our right value of our u here. So u is equal to 4 minus 2x squared minus x to the power of 4. And if you get the differential of this u, we have 0, because the differential of a constant is 0, minus 4x minus 4x cubed. And this is multiplied by dx. Now, simplifying this expression here, we have du, which is equal to the negative 4x. When you factor out this negative 4x in this binomial here, we have 1 plus x squared. And you can check that negative 4x times 1 is negative 4x, and negative 4x times x squared is negative 4x cubed. And we noticed that this one is already in our integrand here. So we will eliminate negative 4 by dividing both sides by negative 4. So du over the negative 4 is x times 1 plus x squared dx. Now, rewriting this radicand here, which is our u, we can have the integral of u to the power of 1/2, because the square root can be expressed as the power of 1/2. And this x times x squared plus 1 together with this dx is our du over the negative 4. So instead of writing that one, we will write du over the negative 4. And factoring the negative 1/4 here, we have negative 1/4 times the integral of 1/2 du. And applying our power rule in integration, we have u to the power 3 halves over 3 halves. And this will be added to our constant of integration c. So simplifying by doing simple arithmetic, we have negative 1/4 times the reciprocal of 3/2, which is 2/3. And this is multiplied by u to the power 3/2 plus c. Now cancelling a factor of 2 in this 4 with this 2 here, we have negative 1/6 of our u, which is this one here, 4 minus 2x squared minus x to the power of 4 quantity raised to the exponent 3/2. And this will be added to the constant of integration c. Thus, this is our final answer for this example number 3. Now let's go to our example number 4 here. What is the integral of x cubed over the square root of 1 minus 2x squared dx? Now looking at this integrand here, we suspect that that would be the right expression to be represented by our u. So u is equal to 1 minus 2x squared. And if we get the differential of our u, we have negative 4x dx, because the derivative of 1 is 0. And dividing both sides of the equation by negative 4, so that we can get rid of this negative 4 at the right, we have this as x dx. Now, looking at our integrand, we can have this x dx from this dx with 1x here. So, rewriting this integrand as x squared over the square root of 1 minus 2x squared times x dx. So this is our du over the negative 4, and this is our u, but we don't have this x squared. But x squared can be obtained here by just adding both sides of the equation by 2x squared. So this is u plus 2x squared, which is equal to 1. And subtracting both sides of the equation by u, we have 1 minus u. So solving for x squared, we need to divide both sides of the equation by 2 here. So by substitution, instead of writing x squared here, we will write its equivalent representation, which is 1 minus u over 2. And instead of writing this radicand here, we will write that as our u, because we represent that one here as u. And our x dx is our du over the negative 4. So this is multiplied by du over the negative 4. And factoring out this 1/2 and the negative 1/4 here, we have 1/2 times the negative 1/4 times the integral of 1 minus u over the square root of u du here. So simplifying this one further, we have negative 1/8 times the integral of 1 over the square root of u minus u over the square root of u du. And applying the integration of a difference, we have the negative 1/8 of the integral of du over the square root of u plus 1/8 of the integral of u du over the square root of u, because the negative of the negative is positive. And applying the laws of exponents here, we have negative 1/8 times the integral of u to the power negative 1/2 du. And this will be added to 1/8 of the integral of u to the power 1/2 du. Because the exponent of u here is 1 and the exponent of the denominator u, which is 1/2, we subtract the exponent. So 1 minus 1/2 is 1/2. So by the power rule, we have negative 1/8 times u to the power 1/2 over 1/2. And this will be added to the 1/8 of the integral of u to the power 3/2 over 3/2. And this will be added to the constant of integration c. So doing simple arithmetic here, we have 1/8 times the reciprocal of 1/2, which is 2 over 1, times u to the power 1/2 plus 1/8 times the reciprocal of 3/2, which is 2/3, times u to the power 3/2 plus the constant of integration c. So canceling a factor of 2 in this 8 with this 2 here, we have negative 1/4 of our u, which is 1 minus 2x squared. And this will be raised to the exponent of 1/2 plus this 1/8 times 2/3 is 1 over 12 times u, which is 1 minus 2x squared to the power 3/2. And this will be added to the constant of integration c. And this is our answer for this example number 4. Now let's proceed to our last example here. What is the integral of the square root of 3 plus x times x plus 1 raised to the power of 2 dx? Now looking at this integrand here, we suspect most of the time that the expression inside this square root symbol is our u here. So let u be equal to 3 plus x. And we notice that the differential of u is just dx because the derivative of 3 is 0. So we can substitute this 3 plus x here to this radicand. But we cannot use this 3 plus x to substitute this x plus 1. So what we will do is we solve for x by subtracting both sides of the equation by 3. So this is u minus 3 is equal to x. So by substitution, we have the integral of the square root of u because 3 plus x is our u here. And this x only is our u minus 3. So this is u minus 3 for this x alone. But we still have a 1 here, so that the expression is raised to the exponent of 2. And the dx is our du here. Now that our integrand are all in terms of u, we can simplify that one as the integral of u to the power 1/2 times u minus 3 plus 1 to the power of 2 du. And then we can simplify by performing simple arithmetic that this is u minus 2, which is raised to the exponent of 2 du. And expanding this binomial here, we have u squared minus 4u plus 4. And this will be multiplied by du. Now, distributing this u to the power 1/2 to this trinomial, we have the integral of u to the power 5/2, because 2 plus 1/2 is 5/2. Minus 4 u to the power 3/2 and added to 4 u to the power 1/2. And of course, there is a du for all these terms here. So, applying the integral of the sum and difference of the terms, we have the integral of u to the power 5/2 du minus 4 times the integral of u to the power 3/2 du plus 4 times the integral of u to the power 1/2 du. So, applying our power rule in integration, we have u to the power 7/2 over 7/2 minus 4 times u to the power 5/2 over 5/2, and this is added to 4 times u to the power 3/2 over 3/2, and this will be added to the constant of integration c. So by simple arithmetic, we have 2 over 7 times u to the power 7/2 minus 4 times the reciprocal of this, which is 2/5, times u to the power 5/2 plus 4 times the reciprocal of this, which is 2/3, and this will be multiplied by u to the power 3/2 plus the constant of integration c. So we have 2 over 7 times u, which is 3 plus x raised to the exponent 7/2 minus 8 over 5 times u, which is 3 plus x to the power 5/2 plus 8 over 3 times 3 plus x to the power 3/2, and this will be added to the constant of integration c. And this is our answer for this last example here. And that's it. If you learned something today, please check out my channel for more videos like this and click subscribe. Click the notification bell below so you'll get notified whenever I'll be posting a new video. Don't forget to like this video to show your support. And always remember to math your way up. Thank you.